Hello there, my name is Arshad and today I shall be talking about my project, the Facial Expression Analysis Tool. But first, let's talk about education before we progress any further. We all know that education plays an important role in everyone's life, and we also know that knowledge is power. That's why there's a heavy emphasis on all of us to be highly educated and to always be striving to study more. And in order to help us with our studies, we have a lot of lecturers in various fields who are able to compress years and years of experience and knowledge into bite-sized chunks so that we students are able to understand them and take them to a higher level. Being a lecturer is not an easy task, but it is an important aspect of society, not only to educate ourselves, to help us in our education, to also help but build a better society. Now I would like you to imagine this. You are a lecturer and you have a classroom of about 100 to 200 students. You only have 1 hour and you have a heavy course that you have to teach. Even though you ensure that each and everyone is attentive and is able to enjoy your class and is able to pay attention, it is not possible to sit and monitor everyone's reaction to this. So what do? The most common way of ensuring that your students have understood what you have taught in class is by asking them, do you guys have any questions to ask? Do you have any trouble understanding this thing? And usually the response that you will get is, no sir, no ma'am, or yes sir, we have understood whatever you have taught in class. Which in fact is a complete blatant lie, because there's always going to be students in your class, irrespective of how good you are, who are going to be struggling or have trouble understanding what you've taught. And that brings us to the second problem, where students are being afraid to ask questions. The reason for this is because if the question that the student asks sounds dumb, then he or she would have the fear that they are going to be judged by their peers, have this perceived connotation that this person is not paying attention in class or is quite stupid. So my solution to this problem is Facial Expression Analysis Tool, or FEAT for short. It is basically a system that is able to generate visual reports that is based on analyzing the facial expressions of the students in class. For this project, I'm actually focusing on 3 major expressions: bored, confused, and satisfied. Here are my objectives. A. To detect facial expression. B. Classify the detected facial expression. And C. To provide visual information via data analytics. Let me now talk about a little bit more about the system architecture. As you can see, all the video recording done for this project is done via an IP camera. These video recording are then transferred to a system where the video is chopped into smaller frames. The reason why we do this is because it helps optimize and helps with the performance of analysis. These frames are then analyzed using our own custom FEAT model, where we are able to detect the faces and analyze the students, whether they are bored, confused, or satisfied. All this information is later stored on an AWS cloud database. The lecturer can view all this information via her browser, courtesy of any device, maybe a laptop or mobile. The website gathers all the information from the cloud database and gives complete access to the lecture in real time if required. As for the system modules, FEAT has 3 modules. 1. Student information. 2. Computer vision. And finally the dashboard. The main objective in this project is focused on the computer vision and the dashboard. The student information mostly focuses on collecting the student data such as the name, metric number, and their image for later student recognition. Let me now elaborate a little bit more on the process flow of FEAT. First, we need to get the input from our video feed. For this project, I've gotten my video feed from the computer lab and from my English class. All this video feed is then converted to frames. This can be set for 10 frames per second all the way up to 60 frames per second. It mainly depends on the duration of the video recording. So if we have a class of, let's say, 2 hours, 1 hour or 2 hours, then it's preferable to set at 60 frames per second. But if it's something short on 10 to 15 minutes, it's preferable to have it at 10 FPS. All these frames then undergo image processing, and under the image pre-processing we have the image compression, grayscale conversion, and thresholding. And after all this is complete, the frames then are sent to analyze. So for the face detection, we use the MTCNN neural network, which has a high accuracy at detecting faces. Then we analyze the expression using the FEAT model that I've built, and later on all this information is then sent to the database, which is hosted on AWS. So before I proceed any further, let me talk a little bit more on the FEAT model, which is a custom CNN model. I built this using the Google Facial Expression Comparison dataset, and I've taken about 7,368 images as a training set. So we have validation split of 0.1, and overall we have been able to get an accuracy of 94% with a loss rate of 0.1. This application was later on tested in real classes, which was my English class and one of the computer courses taught by my lecturer. And during those classes, the system has been able to get about 75% detection accuracy in its deployment testing. The system can be made more robust with additional testing, and there was a plan of integrating facial recognition, but due to the limitation of COVID-19, real-time testing with the students could not be conducted as planned. But it is possible to integrate it, and it's also been noted that recognition of Asian people is more challenging than expected. I shall now play a few clips depicting on how the program works. After we run our FEAT script, the video that we have initially collected is chopped into smaller frames. These frames have already undergone pre-processing. These images will now be transferred to Google Colab to help with our next stage. One thing to note is that the application can be run real time, but to help with the visualization, we have transferred to Colab just for better performance and to help viewers visualize what is going on. So as you can see, the images, after the script has run these images, you can clearly see the bounding boxes along with the expressions that have been analyzed. So we can see most of the students over here are either confused or bored, because that's exactly what they are feeling during this lecture. All of this information, after being processed, is now sent to an AWS Cloud RDS. Once we log into the FEAT website, all the information is presented in a graphical, user-friendly manner, and it's also completely customizable up to the user's preference. We have the information classified into current date, current week, and current month. And we also have a graph that depicts the overall students' emotions over the period of months, such as February, March, April, and even per week. If you'd like, you can click on the button on the side and customize even how the website looks with the colors and the navigation. It's all up to the user's preference. The website also has other features such as the student record and the history record, and all this information can be downloaded if required. All this information in these tables can also be sorted and be searched for your own convenience. To finalize this presentation, I shall now play a video capture of me and my friend together to indicate the expressions that can be detected in real time. Overall, FEAT has been successfully deployed, and as for its future work, we have 3 categories by which we can improve the system much further. That is by adding more facial expressions, integrating facial recognition, and by integrating an ERP system to improve efficiency. FEAT can be taken to the next level. Overall, this project has been successful in its target, and with that said, thank you for listening.